This video is brought to you by MathGalaxy.com. This is the first of two videos on the SAT arithmetic topic ratios and proportions. There are about 2 to 4 of those per test. A ratio is a relationship between two measurements expressed as a fraction. For example, if you go, say, 100 miles in 2 hours. And a proportion shows the relationship between two ratios. For example, if you need to go 300 miles, how many hours will it take? And you can treat these like equivalent fractions. So if you multiply top and bottom by the same number, it doesn't change the value. So for example, here, if you want to go 3 times the miles, it's going to take 3 times the hours, or 6. Another way of expressing the relationship is y is equal to kx, where k is this ratio expressed as a rate, which is 1 in the denominator. So you divide top and bottom by 2, and that would be 50 miles in 1 hour, or 50 miles per hour. So that would be your k. So you would get that from your initial data and then use it for the new case. And on the College Board's official SAT study guide, in their 10 practice tests, these are problems where you can practice ratios and proportions. The notation here is that this is section 2, problem 2 in practice test 2. Let's try some problems. If you want to try these on your own before looking at the solutions, you can pause the screen now. First question, if y is directly proportional to x and y is 20 when x is 6, what is y when x is 9? So we can put that in the y1 over x1 format. Okay, so y1 is 20, x1 is 6, and it wants to know what y is when x is 9. So we can do this by cross multiplication. 6 times y has to equal 20 times 9, or 180. Divide both sides by 6, and y is equal to 30. Second question, if you can make 20 widgets in 2 minutes, how many widgets can you make in 5 hours? So if you want to do this in the y is equal to kx format, the k is this relationship. So we have 20 widgets in 2 minutes. So that's our rate times x, which is 5 hours. So we'd have to convert that to minutes. So 5 times 60 is 60 minutes in an hour. So because if this is minutes, x has to be in minutes. So that's 300 minutes. Okay. And that will give us, that gives us 10 times 300 gives us 3,000. And the units are widgets, because if you've studied dimensional analysis, those cancel out like you cancel fractions. So we're left with 3,000 widgets. Next problem. If you want to try this on your own before seeing the solution, you can pause the screen now. Here, if 1/4 inch on a map equals 5 miles, how long would a distance of 45 miles be on the map? So it's 1/4 inch to 5 miles and equals, if inches is on top, on the left it has to be on top there. And we know the miles and want the inches. So if the numbers are easy to work with, you can do them as equivalent fractions. So 9 times the miles is 9 times the inches, or 9/4 inches, which is 2 1/4 inches. But cross multiplication will always work. So 5 times x is equal to 1/4 times 45. And divide both sides by 5. We get x is equal to 1/4 45 divided by 5, which is 9. So x is equal to 9/4, or 2 1/4 inches. Next problem. If you want to try this on your own, you can pause the screen now. Here, if you can do 3/8 of a job in 24 minutes, how long will it take you to do the entire job? So it's 3/8 of a job in 24 minutes. And the entire job would be 8/8 of a job, or 1. And we're looking for the minutes. So 1 times 24 is 24, is equal to 3/8 times x. And to undo the multiplication by 3/8, we multiply it by its inverse, 8/3. So those cancel out. So we have to multiply this by 8/3. 3 goes into 24. 8 times 8 is 64. So the answer is 64 minutes. Okay, next problem, and as usual, if you want to try this on your own before seeing the solution, you can pause the screen now. Here, if yearly sales were $12,000 and January sales were $2,000, what angle would represent January on a pie chart? So here the two related measurements are angles and dollars. So we have $12,000 dollars. And since it's the entire pie chart, that represents 360 degrees. So now for $2,000, what degrees would represent that? Well, so here as equivalent fractions, if you notice that this is 1/6 of that, the degrees should be 1/6 of that, or 60 degrees. And by cross multiplication, it would be 12,000 x is equal to 2,000 times 360. And dividing both sides by 12,000, we would get x is equal to 2,000 over 12,000 times 360, and this comes down to 1/6, which would give us 60 degrees. Here we have a variation on proportion questions. If you want to try this on your own before looking at the solution, you can pause the screen now. If y is directly proportional to x squared, and y is 2 when x is 3, what is x when y is 16? So this is y sub 1 is to x sub 1 squared, as y sub 2 is to x sub 2 squared. And we plug in our numbers. So y is 2 when x is 3, so it's 3 squared. And we're saying, what is x when y is 16? So here we're looking for x, and it has to be x squared. So by cross multiplication, 2x squared is equal to 9 times 16. And we divide by 2, x squared is equal to 72. To solve for x, you take the square root of both sides, but 72 isn't a perfect square. And we'll be getting into roots in another video. But one alternative, if you're giving answer choices, is to take the square root of this on your calculator and get a decimal and see which of these will give you the same decimal. But the rule for roots is that you can factor it, and if you can factor it into one factor as being a perfect square, that would simplify it. So we can factor this into 36 times 2, and the square root of 36 is 6, so the answer would be 6 root 2. Next problem. If you want to try this on your own, you can pause the screen now. Here, if y is directly proportional to square root of x, and y is 2 when x is 9, what is x when y is 8? So here the relationship is y1 is to square root of x1, as y2 is to square root of x2. And then we plug in numbers. So y is 2 when x is 9. And what is x when y is 8? But it has to be the square root of x. So by cross multiplication, 2 times square root of x is equal to square root of 9, which is 3, times 8, which is 24. Divide both sides by 2, square root of x is equal to 12. And to undo the square root of x, we square it. So x is equal to 144. Here we have a rate problem. If you want to try this on your own, you can pause the screen now. If you remember that a rate is a ratio with the measurement in the denominator being 1. So here A makes 16 widgets per hour. So 16 widgets in 1 hour. And B makes 24 per hour. I want to know how long will it take them together to make 1,000 widgets. Well, 1 hour we have 16 plus 24 or 40. 2 hours would be twice that, 8. So one way to set up an algebra problem is to do a guess and check. Let's go a little higher. Let's just say in 10 hours. Okay. So that's not going to be high enough. So that's not going to be equal to 1,000. So doing a guess and check would take a while to get there, but this will help us set up our algebra. Whatever the true value for time should go here. So it would be 16t plus 24t. T has to be such that that is equal to 1,000 in a true equation. So now we do the algebra. That gives us 40t is equal to 1,000, and divide by 40. We get the time is equal to 25 hours. Next problem. If you want to try this on your own, you can pause the screen now. Here, A takes 16 hours to complete a job, B takes 24 hours to complete the same job. How long will it take them if they work together? They're working together like the last problem, but you don't have a total output that you're looking for. And it's not obvious that it's a rate problem. For a problem like this, talking about a complete job, I like to draw a box representing the job. You could think of it as a fence being painted, and that A starts at one end. For example, if A takes 16 hours to complete the job, so you can represent this as a rate that A does 1/16 of the job in 1 hour. And likewise, B, starting from the other end, can do 1/24 of the fence, or the job, in an hour. So they sort of work towards the middle. In 2 hours, A would do another 16th of the fence. B would do another 1/24 of the fence. And you want to see how many hours it take till all these add up to one whole fence. So the rate is, for A, is 1/16 of a fence in 1 hour times the number of hours is the fraction of the fence that A would do, and B does 1/24 of the fence in an hour. So multiply that by time, tells you what fraction of the fence B does in that time, and it has to equal one whole fence. So now we have to solve this, and so you could convert these to decimals and solve it that way, but another way is to get rid of the denominators. It's like to get rid of the 16, we multiply both sides by 16, and that gives us t, and then 16 times 1/24 is 1/3, no, excuse me, 2/3. 16 over 24 reduces to 2/3. Now to get rid of the 3, we multiply both sides by 3, so we get 3t plus 2t is equal to, we have to multiply this by 3, is equal to 48, and 5t is equal to 48. 8, divide both sides by 5, t is equal to 9.6 hours. Here we have problems involving ratios with totals. If you want to try these on your own, you can pause the screen now. First problem. If the ratio of dogs to cats to fish in a pet store is 5 to 4 to 3, and there are 60 pets in the store, how many are fish? Well, if this were a standard ratio with just 2 items, you would say there are 5 dogs to every 4 cats. And let's say there were 12 cats, then how many dogs there were? So it would be 3, the multiple would be 3. So 3 times the cats and 3 times the dogs would maintain the ratio. But for problems with totals, then you'd also have to have a total line. So in your base case, there would be 9 total, and whatever you scale this up by, you'd have to scale that up by, so there would be 27 pets. So here we're just extending that to 3, so we have dogs to cats to fish. For every 5 dogs, there are 4 cats to 3 fish. And then if we did our total, it would be 12. And we could scale this up by any multiple and still maintain the ratio. So 10 to 8 to 6 would also be true. But how do we scale it up to a total of 60? Well, we get the multiple here, which is times 5. So that's the trick here. You're trying to find, you have to have the total line, find what you have to scale it by, and so we scale each of these by 5. So we get 25, 20, and 15. And you could also express this horizontally as 5x plus 4x plus 3x is equal to 60, and solve that. And you always want to take an extra second to make sure that you're giving them exactly what they want. So here they're asking how many are fish, so the answer would be 15. Okay, next question. If the ratio of dogs, cats to fish in a pet store is 5 to 4 to 3, what is the possible number of pets in the store? Well, from here, it's obvious, it's 60. But in this case, the trick is that you have to get the total factor. So we scale this, it would be 5x to 4x to 3x is equal to 12x. And for these type problems, x has to be a whole number. You can't have half a dog. So the correct answer has to be a multiple of that sum, or multiple of 12. It could be 12, 24, 36, and so on. Next problem. If you want to try this on your own, you can pause the screen now. Here, A has 5 times as many pins as B. What is not a possible total number of pins? So for every 1 pin B has, A has 5. So they're looking for a total, so you need a total line. So 6 is a possible number, and again, if we scale these up by any whole number, it'll still maintain the ratio. So that tells us total number of pence has to be a multiple of 6. So 20 is not a multiple of 6, and that's what they're looking for. 6 times 5 is 6 times 10, so those are multiples of 6. 6 times 15, and 6 times 16. That's the end of the first of 2 videos on ratios and proportions. And if you want more practice, you can find them in these problems on the College Board's official SAT study guide. So good luck with the test.